Hello friends, welcome to Joy of Life again. Today we are going to look at a medium level problem from Leetcode. Problem number is 3. It's a medium problem. The problem statement is pretty straightforward. It says given a string S, find the length of the longest substring without repeating characters. So we need to find out the longest substring which doesn't have a repeating character. Two important part over here. So we'll see some of the example given with the problem. So if we have a string like say ABC, ABC, BB, here we can say that ABC is the longest substring without the repeating character. Either this ABC or this ABC doesn't matter. So we will just take a quick look and understand what a substring is before we proceed with the problem. So let's say I have a string like ABCDE. So any contiguous portion of the string that we pick up, AB or BC or CD or CDE or just E or the entire ABCDE or BCD, whatever, is a substring. These are all the substring, the underline part. So basically a substring has to be contiguous and the character should be next to each other. For example, if I say AB and D or ABC and E or A and CDE, these are not substring. So as you can see that the line is broken in between, right, between each one of them. So we cannot call them as a substring. For substring to qualify as a substring, the line should not be broken. Or in other words, the character should be adjacent to each other. So what are these called? These are called subsequence. So in this case, we can see that ABC over here is our answer. So the result would be 3, the output, as you can see here. If we have a string like BBBBB, so either one of the B would be your answer. The answer would be 1. So again, for input like PWWKEW, here the longest substring without repeating character is WKE. We cannot include the P. If we include, you can see that the line is broken over here. So if the question would have been longest subsequence without repeating character, this could have been qualified as an answer. But in our case, it will be only WKE, sorry, not WKE, which is 3. So as I always say that do give it a try yourself, try to solve this problem. You will get some idea. It's just a simple string manipulation. You can try the brute force approach at least, and you can pause the video here, try your solution, and then you can anytime come back to this video. So let's look at the solution. So here we are in the blackboard, I'll call it, and we will look at we'll go at a multi-step approach to this problem. First we'll see how we can solve this problem, then we'll do a dry run, and then we'll go to the code. So let's start discussing the solution. So the technique that we are going to use to solve this problem is called sliding window. So the sliding window can be of various type. It can be a fixed window, a dynamic window. A fixed window means the size of my window is fixed and I just move it around. And a dynamic window is where I adjust my left and the right bound based on my uh, constraint of the problem. So here we are going to use a dynamic sliding window in order to solve this problem, and we'll see how. So when I say a sliding window means a window, right? A window of a certain size. So when I say a window of a certain size, we need to have a left pointer, which indicates the left side of the window, and a right pointer, which indicates the right side of the window. So we'll call them left LPTR and RPTR. And we also at every point need to check the size of our window, so that will store it in say win. And at every point we'll have a window of the different size, and we need to see when we can find the maximum size window that we are looking for without repeating characters. So that we are going to store it in max. So these are our 4 variables, and also with that what we need is a set. So whenever we see a character, we are going to store it in set, so that we know that when we say we get a, we store it in the set. Whenever in future we see another A, we should be able to identify that we have already seen a or not. So that is where our set is going to help us. So the set is initially empty. So I am just giving you the algorithm over here. The left and the right pointer both are at 0. So initially when I start, so both are at the starting position of the string. Then I am going to adjust my window size based on different constraints. So initially both are pointing to the same index, and that is the leftmost index. And initially our window size is 0 and our max is also 0. So initially when I'm starting, so I'll consider these as my init params. So these are what it is initialized to. And then I am going to start a loop. So the loop will have two exit criteria. So as I told you, the right pointer would be going ahead and creating a window. So the right pointer, if it crosses the boundary of the string, that is one exit criteria for me. So as long as my RPTR is less than input dot length, that is my first condition. And my second pointer condition is it might happen that the left pointer overlaps the right pointer and tries to exceed it. So the left pointer should be less than my right pointer. So these two are my criteria. And inside the loop, what I am going to do is I am going to look at the character denoted by RPTR, right pointer. So the right pointer will move. We'll see when we do a dry run how the right pointer will move. So we will always try to see the character denoted by the right pointer and try to come up with the solution. So, and if so, there can be two scenarios over here. The first scenario is I have seen this character previously, or I have not seen this character previously, and that is maintained through this set. So one condition is if set contains ch, and the other part is my else part, if I have not seen this character previously. So let me adjust it over here. So let me get some space over here for you. Yeah. So if I uh, see this if let's concentrate on the else part, that I have not seen this character. So what I am going to do is I am going to increment my right pointer. That is the first thing that we are going to do. That we will increase our right bound, and then we are going to add this character ch to the set, because we have seen this character now. Say we got a, first thing we do is we increment the right pointer, and then we are going to store this right pointer so that we know that we have seen this character. And we are also going to increase our size of the window. Now the two pointers are at the, say, at 0th index. Now I increase my right pointer. So what happens is the window size increases, right? So I need to see that I need to ensure that I have the right size of the window with me. And then I am going to update my max. So I am going to store in my max, I'm going to store whatever is bigger between my max and my current window. So you can, so initially my max is 0, right? Now my window has increased. So I know I have seen a substring without repeating character of size 1. So I am this what it will do is it will update my max. And what if I get a character that I have already seen previously? So in that case, I am, so let's say this is my window and I see that I have a character that I have already seen. So I need to remove the character, remove. from set. So what I am going to remove from set, the character denoted by the left pointer. We'll see in more details why we are doing this. And since I am, see this is my window and I am incrementing my left pointer. So I am moving my left pointer towards the right pointer. What this will eventually means is I am making my window smaller, right? The window is getting shortened. So I am going to reduce the size of my window in this case, right? So when I extend the right, my window increases. When I extend the left, the window becomes shorter and shorter. So this is the whole algorithm. And when we exit out of this loop, I just return whatever I have in max. So the max contains the answer to the problem at the end. Okay. So we will see in much details on how we are getting the result using we'll do some dry run in order to see this. So first let me generate a string for you. So let's say I have a string like A, B, C, D, C, and then A, B, C, D, E. So let's say this is what we have initially, and I'll create the empty set, which is initialized at an empty state initially. Excuse me. And then, as I told you that I have the LPTR, RPTR, win and max, and all of them are initialized to 0. So this is my init condition. This is my init condition, and we enter the loop and we do our operations now. Okay. So let me change the color. So the loop starts with the left pointer and right pointer both at 0th index, right? So let me put the indexes for you. So both starts at the 0th, and as I told you that we are going to see what is denoted by the right pointer. So here I see uh, right pointer points to 0. The 0th character of the string is A. So I check going by this algorithm that we have shown here on the right side is when I see A, first I check if it contains in the list or not. If it doesn't, we are going to put A inside it. So let me create some space for you. So we are going to put A inside this list. And what we are going to do, so 0 to 0 is just one character, which is your A, the first character over here, that is A. So I see a window of size 1. So when I says let me depict it over here for you, it will be easier for you to visualize in that way. So let me take a smaller, even smaller pen. So this is your, okay, no, sorry. So 0 to 0 is nothing but here, both points here. So what happens is we get a window of size 1 and your max becomes 1. Why 1? Because we are taking the best between win and max. Whichever is higher, we are taking that. So as we have encountered a character which is not present in the set, what we are going to do is we are going to increment the right pointer by 1. Let me get some space. Yeah. So what happens with that operation is your left remains at 0, your right comes to 1. So right comes to here now. So left is sitting here and right is sitting here. So we have created a small window over here now. As you can see that now our window is coming to life. And what is denoted by the right PTR, which is 1, which means B. First we check in the set, do we have B in the set? Oh no, we don't have B. So we add B to the set and we get a window of size 2 now. Because A to B, you can see that there are 2 characters. and it beats our current max, so we put 2 here and increments our right pointer. So the right pointer comes to 2. So when I say 2, that means we have a window this big now. So what is denoted by 2? C is denoted by 2. So we check in this set, okay, C is not there. So we are going to put C into this set, and we're going to say we have seen a window of size 3, and 3 is the best, and we increment the right pointer. So this guy comes to 3 now, and this remains at 0. So we have a window like this now. So what is denoted by 3? It's D, and we don't have D in the set, so we put D in the set. And now we say that we have seen a window of size 4, and this becomes 4, and this goes to right pointer plus plus. So this comes to 4, this is at 0. So what happens is, in this case we have a bigger window. So as you can see that our window is growing because we are not encountering any character that we have previously seen, and that is ensured by this set, right? So now at index 4 we see a C, and we see that C is already present here. So what we are going to do in this case is we are going to first decrement our window size. Our best remains at 4. So now we know that we have seen we are in a position, the right pointer is at a position wherein we see a character that has already been seen earlier. So we are going to remove from set the the character indicated by the left pointer, which is 0, means A. So we are going to remove A from this set. Why we are going to remove A from this set? Because we are going to increment our left pointer now. So we are going to increment our left pointer. So what happened is I got A, I got B, I got C, I got D. Now a time has come when I have seen C, and this right become fixed now because this is no more a window that has an and so this is no more a window that has no repetition. This is a window that has repetition. So I will remove A and check. I'll remove B and check. I'll remove C and check. So initially the left is at A. So I removed A and I'll be checking. That's why I have incremented my left pointer over here. So when I incremented my left pointer, so left come to 1, right remains at its own place. So we are in a window like this, and A has been removed. So again we go and check that the character represented by the right pointer, which is C, is it C present over here? Yeah, C is still present. So we are going to remove B, and we decrement our counter. So our max remains same, and we increment the left pointer. So max is only ensuring that what is the best window I have seen so far, and that window is 4. 4 means initially when we have seen a window of size 4 starting from A to D, right? So I increment the left pointer and I have removed from here. Then I increment left pointer to 2, and this guy remains at 4. So 2 to 4, again check that do I have a window where I don't have any repetitions? So where is 4 sitting? 4 means C. Is C present on my set? It is still present. I cannot move any further. So I remove so I get a window of, so I'm going to remove first the character indicated by 2. The 2 means C. So I'm going to remove C. And I can say that I have seen a window of size 1. So I'm not considering this, and my left pointer will continue to go further. So I come to 3, 4. So 3, 4. Okay. So what happens over here? So I am I am at I am at character starting from D to C. So in from D to C, what happens is I again check with do I have the character represented by R right pointer in the set or not. Okay, this time it's not there, so I add C over here. So from the window 3 to 4, which means this window, it does not have any duplicates. You can see here. So I just put it to 2, and my best still remains at 4. So you can see that 4 is now my window is free. We have come to a position where we don't have a repetitions anymore. So I can freely increment my right pointer. So the right pointer comes to 5. This stays at 3. So 3 to 5 is a window that has been created here. So what I get in the right pointer now, I get a B. I check that do I have a B in my set? No, B is not there. So I put the B and I can increment this, but uh, this does not beats my current max window that I have seen so far. So it still remains at 4 and I increment my right pointer. Okay, so this remains at 3 and this goes to 6 now. Yeah, so this goes to 6 now. So I have a window of this size now. So what is pointed by my right pointer? I did a mistake. Okay, my bad. This would be A actually, not B. A was also not present, right? It was been removed previously. So now it points to B, and I go and check that does B exist over here? I see that the B doesn't exist, so I put B over here. So 3 to 6, again, I see a window of size 4, and it does not beat my current maximum. So I increment my right pointer. So the right pointer comes to 7, left pointer is still at 3. So I get a window of size this. So what is pointed by my right pointer? It is pointing to C, and I see that C is already there. So again, I came to a position wherein I can't do anything. So I need to I need to increment my left pointer, and before I increment, I should decrement the size of the window from 4 to 3. And what I should do, the character pointed by the left window, which is D, should be removed from this set. And I do not touch my max, and my left pointer this time increments. So what happens when the left increments? It comes here. So this becomes my new window. So this will be from 4 to 7. So again I say, check what is indicated by 7, C, and C is still present here. So what I am going to do, I am decrement my window size and remove the character from the set, and my max doesn't change, and I increment my left pointer. So when I increment my left pointer, it comes to 5, and this still remains at 7. So over here you can see that it becomes this. So what is indicated by 7? C is indicated by 7, and C is not here. So I am going to put C. I am going to increment this, and I say that my right pointer is 4. So since I was able to see a character which is not present on the set, which is indicated by the right pointer, now I am free to move my right pointer. So this still remains at 5. This goes to 8. And now my new window is created here. So what is indicated by my right pointer? D is indicated. Does D contains in the set? No, it doesn't. So we add D to the set, and what we do is we increment the size. So it still does not beat our best. We increment the right pointer. So what happens here? It goes to 5, it goes to 9. So we get a window of this size. So what is indicated by 9? E is indicated by 9, and the E is not here. So we are going to add E over here, and our best, current window size becomes 5 characters, and it beats our current max. So 5 becomes the answer in this step, and we increment the right pointer. As we increment the right pointer, right goes to 10, left remains at 5. So here you can see that this is now going beyond the index, and which is one of the uh, criteria for us to exit the loop. So we exit out of this loop and we have our answer stored in the max. So this is the entire dry run of the problem. Here you can see that how we started creating a window, and at every point we have a question that have we seen this character? If we have seen this character, we are adjusting the left, and if we have not seen this character earlier, we are adjusting our right. And we have, as you can see, that we at different point we have a window of different sizes. Here we have a window of size 1, 2, 3, 4, 5, 6, and so on. So you can see in this entire problem, sorry, this is not 6, this is actually 4. So it's dynamically changing size of the window. So it's called a sliding window. The window is sliding based on the constraint we have for the problem. So this is the whole approach on how to solve this problem, and we have the algorithm also on the right hand side. And now we'll quickly see how it looks in the code. It's not going to differ a lot. It's going to be very similar to what we have done. So just a couple of checks that I'm going to add, that if I get a string input which is null, or the length of the string that is provided to me is 0, so in that case we can simply say that the answer is 0. So this is just a check that we are enforcing over here, and just to safeguard the corner cases. And then we are going to do as we have discussed on the whiteboard. So we are going to create a set of characters, and we're going to call them scene, though we have not used a name there, but when you declare a variable you need a name. So we can call this and we talked about left pointer, which is at 0, and initially the right pointer, which is at 0. And we are going to store the window, and we are going to track the max. So max is initialized to 0, and at the end, as we discussed, that we are going to return the max. So these are my these 5 are my my initialization parameters that we have discussed earlier in the whiteboard as well, right? So nothing but these and the empty set. Okay, so we are going to put down the two constraint that we talked about, that is right pointer should be less than string's length. If it exceeds, then we need to break out of this loop. And left pointer should be less than or equal to the right pointer. So at any point of time, it can overlap, but it should not cross and go. Okay, so that is one constraint, that when I'm incrementing my left pointer, it is allowed to come till my right pointer. It is not allowed to go past it. So that is what we have given here. And now we'll get character by character. And as I told you, that we are going to get the character denoted by the right pointer. Sorry. So we are going to get the character, and we are going to see if scene dot contains, that we have seen this character previously or not. These are the two things that we have discussed, right? So this is nothing but these two conditions, right? So what we are going to do, if it contains the character, if the set contains the character that we are at currently, that we have already that means we have already seen this character. In that case, what we are going to do is, we talked about, we are going to reduce the window size. We are going to increment our left pointer. So when we see a character that has already been seen previously, we are going to move the left pointer, which in turns will make the window size smaller. So when minus minus, and the left pointer is pushed one step, right? And what we are going to do, and we have to remove that character from the set, which is denoted by the left pointer. So before we increment the left pointer, what we'll do is scene dot remove, and we are going to remove what is it now? S dot char at lptr. So we are going to uh, sorry, we are going to remove that character which is denoted by the left pointer from the scene set and then increment our left pointer. Other and if so that is all. This summarizes everything that we want to do when we see a character that is already present in the set. Otherwise, what we are going to do, as we talked, we are going to increment our window, and what we are going to do, we are going to increment the right pointer, and what we are going to do, we are going to add this character denoted by ch into our um, we are going to add this character to our set. So this is all. This is what uh, the algorithm is all about. And also at every point when we are setting the window size, what we need to do is to store the max somewhere, that this is the max window that we have seen so far. So if the current win is okay, so we are going to take whichever is greater, the current max or the window. Window is nothing but the size of this window that we are talking about. So let's run this code. Mm, oh, sorry, it's the function sign. Oh, sorry. So you can see that our answer has been accepted. So let's try with the test cases that we tested with A, B, C, D, C, A, B, C, D, E. So you can see we get the answer A, B, C, D, E, which is 5. And let's do a submit and see how it goes. So it's being assessed at the moment. Okay, so here it has been accepted, which has a runtime of 6 millisecond, faster than almost 70% of the submissions. Memory usage is less is 38.8 MB, less than 95% of the online submission for longest. So since we have not used any not much of the extra space except for this except for this set, and in this set we are only storing the unique characters. We are not going to store each and everything over here. So yeah, there are scope that you can improve this, but the whole point for me is to give you the idea on how to approach and solve this problem. Hope you like the solution. Do like, share, and comment. It will encourage me to create more videos. It's been a while I created a video, and I will definitely try to keep up the pace and come up with more videos. Thank you once again for watching. Have a great day. See you guys. Bye bye.